All right, so let's start looking at kinematic graphs. And the first graph we're going to have is a position versus time graph. And that's where the y-axis is the position, the horizontal axis is the time. Okay, and so the slope, right, is going to be the change in the y variable over the change in the x variable, which we know from our formula. Remember, v average, average velocity, is that displacement over time. It's just a question of whether or not that's in slope at a particular point. That would be called the instantaneous velocity versus the slope between 2 points or an interval of time. That we would call the average velocity, right? And then the area of a position time graph is given by this formula. It's the y variable times the change in the x variable, but that doesn't have any meaning. We don't have any formula, so there's no physical meaning on that. So let's take a look at this problem here, an example problem, and make sure we understand that. So when we have a position versus time graph, what you want to do is you want to say, well, we know the y value is the position, and we know the slope is going to be that change in that y variable over that change in that x variable, and that is the velocity. Now, whether it's average or instantaneous kind of just depends on the context of the question, but we want to keep that in mind. So we have a graph of a position of a card as a function of time is given below. Assume that the positive direction is to the right and the negative direction is to the left, okay? At what time is the card at rest? So first thing we have to do is we have to interpret the wording of this into something related to our kinematic variables, and this is where the velocity is 0. At rest means the velocity is 0, okay? That's one of those key words that we did. So if the velocity is 0, and we know the slope is the velocity, we're looking for times where the slope here is going to be 0. Slope of this position versus time graph is 0. And the slope of 0 is a horizontal line. So segments here and here, right, between 2 and 4, and between 6 and 7, is where the velocity is 0 because the slopes are 0. Everywhere else has some slopes. And that should make sense because the y value is the position. See, when he's at rest, the y value is not changing. It's just he's located at x equals 15 and it's not changing, right? It's just at 15, at 15, at 15, at 15 the whole time. And so that makes also another sense just from making why that means at rest. At what time is he moving to the right? Remember, the direction of the motion is the sign of the velocity. So that is where moving to the right is where the velocity is positive, because we said right is the positive direction. So when the velocity is positive, it's moving to the right, and that is when the slope is positive, right? So when does it have a positive slope? You got to remember in your from your math days, positive slope is up and to the right. So here it has a positive slope, 0 slope, negative slope, 0 slope, negative slope, positive slope here. So these two times, it has a positive slope, and so that's where it's moving to the right. So it's moving right between 0 and 2 because the slope is positive, and between 8 and 9 seconds. Okay, cool. Now, when is it moving to the left? That's when the velocity is negative. The sign of the velocity is to the left, right? And so that's when the slope is less than 0. So it's moving left at what times? Let's pick a different color. When do we have a negative slope? Here and here. That's when it's down and to the right. That's a negative slope. And so that's going to be between 4 and 6, right? And then between this times here, 7 and 8. Okay, so like that. At what time does it have maximum speed? Now, we got to connect that. Remember, think about what we did on the kinematics is that the speed, okay, the speed is the magnitude of the velocity, absolute value of the velocity, and the velocity is the slope, right? So which one has, so let's just look at what the slopes are in various places. So the velocity here, that slope is going to go over 2 and up 5. So that's 5 over 2, and that's 2.5. The slope here is 0, so here the velocity is 0. Here the velocity is this slope, goes over 2 and down 15, so it's minus 15 because it falls 15, it goes over 2, and that's negative 7.5. This slope here is 0. This velocity here, again, goes over 1 and down 15, so that's minus 15 over 1. That's negative 15 meters per second. Don't forget the units here. And so when does it, now the absolute value, now you might think like, well, this is the biggest number because it's the most positive, but this for speed point of view, we don't care about if it's positive or negative. Oh, we forgot about this one. This one is it goes over 1 and it up, not up 1, up 5, right? It goes from negative 15 to 10, it's up 5. So that's positive 5 over 1. That would be 5 meters per second. Now, which one has the greatest speed? That's the absolute value, right? So if you look at it, 15 meters per second. So it's the 15 meters per second is the max speed at between t is between 7 and 8 seconds, right? In this interval right here. That's when we have the maximum speed. And that's where it's technically the velocity is negative 15 meters per second, but that just means it's moving to the left at 15 meters per second, right? The speed itself is 15. Let's take a look at this problem here. So the graph represents position versus time. So against the y value is the position. And then the slope is going to be the change in that y variable over the change in that x variable. And that's going to be the, change in the y variable, which is x. So that's going to be velocity. Now they're telling you it's a constant force. Force, don't worry about that part. The average speed. Now we're looking at the slope, and it's between 2 points in the interval. So we're looking at the slope between 2 points, between 1 and 2 seconds. We want to calculate the slope of that line. That would give me my velocity, but then I just take the absolute value to get the speed. So that's going to be the displacement. So let's see, we're going to go over 1 here. And what's the rise? You're going to go from about 2 to about 8. So that's 8 minus 2. That's 6. So that's going to be 6 meters. And the top unit is meters, right? And then the bottom unit is seconds, right? Because this is meters, this is seconds. So it would be meters per second. So that's 6 meters per second there. Thanks for checking out this video. I hope you found it really helpful. If you'd like more support, maybe you need more multiple choice practice, maybe you just need more guidance and things like that, I have plenty of information on my website. If you look in the description below and go to www.bothellstemcoach.com, I will explain all the ways I help students be successful in their AP classes.